introduce our last speaker of the design fair, Paul Graham. He has his own IT consulting business and he's worked extensively with the Mars Society. He is the project manager and the I'll just briefly describe what OpenLuna is. It aims to return mankind to the moon through private enterprise. Initial goals focus on a step program of robotic missions coupled with extensive public relations and outreach. Following these piloted robotic missions, a short series of manned missions will construct a small settlement at a chosen location. So without further ado, I would like to introduce Paul Graham.
So, who likes that picture? Who wants to see that picture for real? That's most of you. Okay, well, I'm done. That was easy. All right, next. No, seriously. I mean, don't you think we've waited long enough? It's been a long time since we've been there last. That's what we're trying to do. And that's how I originally intended to start. But then I saw today. Today was really amazing. I saw some really spectacular work today. Y'all did a really good job. I mean, y'all should really give yourself a good hand. After we thank him for having his phone on, I mean, honestly, y'all did some really good work today. I've seen some really spectacular designs. I saw some amazing attention to detail. I saw a couple things that you probably might want to open up a physics book or two. But overall, I was really impressed. And now the question is, now what? What do you do tomorrow? Today was cool. Most of you did this just as extracurricular. It didn't really mean anything to your grade, right? You're just doing this because you think space is cool. Well, what do you do tomorrow? Now, I'm not sure, but I think I'm required by law to give you the, stay in school, get good grades, work hard speech. I think that's what people are supposed to do in these events. But I don't think I need to worry about that in this crowd. I mean, y'all are going on to school, right? And is there anyone here who does not plan to go on to university? Okay, good, because I'd make you leave. So that's just obvious. If you're going to keep on doing this, go to school, get good grades, work hard. Okay, done, I did that. Why? What's next? Why would you want to do something like that? Well, you heard Grant talking this morning. There's a lot of cool things to do out there. There's a lot of cool companies. Canada's space industry is at one of those really rare places where cool things are about to happen. Capital C, capital T. Some really neat things are just starting to happen in Canadian space. The Americans are bowing out. They basically said, I'm done. They're going to keep on trying. They're going to do some things, but they've given up on the moon. They've given up on low Earth orbit. Who's going to fill in the gap? Chinese are, sure. The Russians have decided they're just doing mercenary work. They'll fly if somebody pays them. That's okay. We need somebody to fly. Canada's in a really unique position now, though, to step up and take leadership. Now, I'm not going to turn this into a bash other space agencies talk, because that ain't it. They're doing some amazing work. They're doing some really cool things. In fact, we're going to talk with some people this afternoon at NASA who are going to do something that will just blow your mind. It is amazing. You're going to have a lot of fun with this, trust me. But the other group that's really stepping up is private industry, private space. Almost all of Canadian space is private space. You got OPDEC, MDA, the usual suspects. And then there's other interesting things happening. Who here has not heard of the Google Lunar X Prize? Okay, maybe let me do it the other way. Who here has heard of the Google Lunar X Prize? Because I want to see motion. Okay, cool. So that's one group that's trying as hard as they can to put things in space. Things are cool. Let's take this another step further. Let's put people in space. Now you're going to say, well, wait a minute. Okay, that's really complicated. It took NASA, it took an entire country's output to put a few people in space 40 years ago. I say it can be done differently. And now I'm going to tell you how. Now, this is a presentation that normally takes an hour. If I try really hard, I can get it down to 20 minutes. Today, because of the energy I saw of you, I'm going to do it in 10. So don't mind me if I move really fast, okay? There's going to be questions afterward, but there's going to be a little demonstration in the middle. I'm going to answer questions while you're involved in the demonstration. Trust me, it will make sense. So, as she said, I'm Paul Graham. I'm president of OpenLuna Foundation. I'm project manager of OpenLuna.org. At some point, I'll explain the difference. And as she said, our intention is to build a 6 to 10 person outpost on the lunar surface in the next 5 to 7 years, and we're going to do it for $500 to $700 million. Yes, I know what I'm saying. Yes, I understand those numbers are an order of magnitude cheaper than you think they ought to be. I will tell you how. That's the slowest I'm going to take. This is an example of what we intend to build. This is our Cadillac outpost. This is if we get all the money and everything goes exactly right, we're going to build this. How are we going to do it? Well, what are we going to do with it? Scientific interest, surface exploration, tourism, of course, there's got to be tourism. That seems to be the only thing driving people into space anymore, and mining exploration. Okay? You hear about hydrogen. How many of you today said, we're going to take resources from the moon? Yeah. And how many of you have see any real capability of that? There's none. So this is how we're going to build it, okay? We have 4 mission classes. Our Scout class is this light little thing, and what it's going to do is basically drop some rovers on the surface, look around, decide where to go next. What we're calling a boomerang class, where we bring back samples. These are just artist rendering, don't worry about it. We have our Pathfinder classes, where we're going to send a person. This thing right here is not a mock-up. That thing has flown. Right there is a lot of the pieces from it. This will give you an idea of how small this thing is. This thing this thing all put together weighs 50 pounds. The one we're going to send weighs 75 pounds. It has flown. You know, you can say all you want about it. It's flown. That's kind of good enough. And then our Explorer class is when we actually build this thing, build the outpost. We're hoping to develop 2 launch vehicles. It'll stage something like this. Like I said, I'm going really fast. Bear with me. You can ask questions later. It'll look something like this, kind of a horizontal staging rather than vertical. And it works. I'm going to skip the numbers, but I'll let you look at them for a minute. You know, our Scout class, it's a one-way mission, lots of margins just to kind of give us some room to work. Short hops around to deliver these rovers. Boomerang class, this is where we're bringing the samples back. Now there's one number you keep on seeing. We're going to deliver 225 kilos, we're going to bring back 225 kilos. Why? Because that's what we think a person and his consumables, his suit and such, will mass. Now we've tested our lander and tested our return system in their environment. So then when we go to send a person, it's not as crazy as it sounds. 1 person in a suit, no capsule. 2-week stay. They'll bring a tent for emergencies, but that's just for emergencies. I can tell I'm losing somebody here, so I'm going to take a second to tell you about it. What do you really need a capsule for? People, air, okay, a suit can provide air. People will say micrometeorite protection, maybe. It doesn't help. There's nothing out there that won't go right through the skin of a spacecraft. And now you've got a bigger target rather than a tiny little target. Temperature regulation. You can do that, the same thing with a good suit. The suits that we're using will cool by themselves. They allow you to sweat through them. So that gives you cooling. What our intention is to have solar panels on this lander, and then you kind of duck behind the solar cells as a parasol, so to speak, to let you cool down a bit, or if you need to, you get outside and warm up a bit. So you've got that there. That also gives you some radiation protection, because a lot of the radiation that you need to worry about isn't cosmic radiation, and a capsule won't help you with cosmic radiation. In fact, it might be counterproductive. You know,
G-forces?
There's no G-forces in space. Not once you're in orbit, there's not. Takeoff and landing, you'll be in an aero shield, you know, and you'll be supported enough. Landing, you'll be on your back in an inflatable heat shield. Did I say that? Yeah, inflatable heat shield. There's been some studies on that. Georgia Tech's done some good studies on that. GE's done some good studies on that. The ESA has done some good studies on that, along with the Russians. Inflatable heat shields will work.